as we did yesterday, right, we did some optimization with restriction. So we're going to do optimization with restriction. So whenever I have restriction, I cannot use the cube because now things have changed, right? So it's not, to give me the optimum volume or the optimum area, it's not going to be the optimal minimum surface area. It's not going to be a cube. So the constraints may be, the dimensions may have to be whole numbers or be multiples of a given number, or sometimes one or more of the sides of the object are missing or bordered by some physical barrier. Do you guys remember yesterday making the swimming pool, right? We had one of the sides of the, what was it? It wasn't swimming pool, it was garden. Yeah, and we had the house, right? One of the sides of the house was part of the garden, right? So we had the restriction with that we don't want to fence the fourth side. In these cases, the optimal rectangular prism will not be a cube, okay? So in this case, when you have restriction, either it has to be whole numbers or multiple of given numbers, or let's say if they don't want to make a top of it or they don't want to make the bottom, then you have restriction. It's not a cube anymore. So how can we solve this? In this course, we use tables or we use pictures, okay, diagrams, to solve for the new rectangular prism. So let's look at, so Jacob is designing a glass candle holder. It will be a square-faced rectangular prism with outer surface area of 225 centimeters squared and no top. So there's two things here. It's a square-based rectangular prism, so my base has to be a square, and there's no top. But what he wants to do, he wants to maximize the volume. Okay? So he wants to have the maximum volume possible with this shape. So we have a square at the bottom, right? We have candle holder with no top. Okay? I know I can't draw. That's okay. That doesn't look like anything like a cube. So I know that my bottom have the same size. Now how would I do this? So let's look at my surface area, because what's given to me is a surface area. So I have to start with a surface area. Okay? So what's the formula for the surface area of this type of rectangular prism? What's the area of the bottom, of the base?
Length times what?
But the length and the width are the same.
So 2a squared.
So a squared or L squared or whatever you want to call it squared. Okay? As long as you label your picture, okay, it doesn't matter what letter you call it. So the area of the base is L squared. Now, how many other faces do I have?
4.
I have 4 other faces, right? So I'm going to call this H. Okay? What's the area of this face? What's the area of this face? Length times height, right? L times H. What's the area of this one?
Same thing.
Same thing. What's the area of the back?
You can just go all times each times 4.
That's right. I have 4 faces. They're the same,
4.
right? Their area is L times H. So that will be plus for LH. Are you guys okay with this so far? So in this case, when you have restriction, you have to make up your own formula. Okay? It's not similar to the one that you have in your green duotang. Now, I know that my surface area is 225 and it's not going to change. I don't know my L, I don't know my H. So this is where I have to pick numbers for L and solve for H. Or pick number for H and solve for L. Which one is easier to isolate for, H or L? Hagen? H. Why H? There's only one. Right? There's only one H. There's two L's. It's very hard to isolate for that L. Okay? So let's try that. So let's isolate for H. What do I have to do? Bring the L squared over, so it becomes negative L squared. And then divide by 4 L. Right? Do you guys understand that?
It sucks, but yeah.
It sucks, but yeah.
Oh yeah.
So now, if I plug in values for L, I can solve for H, right? So I pick some values for L here, 1 to 10, okay? So all what we have to do, we have to plug in the values for L here, right? And solve for H. And then I have L and H, and then I can find the volume, and then from there I can decide which one would give me the maximum volume.
Oh, that's not that. You made it sound easier there. I
So,
thought it was. I had to make all the numbers up myself.
so to solve for H, I just use this formula. Okay? Volume, what's the volume of this specific shape? Length times width times height, but in this case it will be what?
Length times length.
Length times height, which is length squared times height, right? So the volume, the formula for it is L squared H, right? Okay, so I know my formulas. All what I have to do is plug in values for L, solve for H, do the volume. So if L is 1, 225 minus 1 divided by 4, what do I get? So 224 divided by 4. Okay, so all what I did is I plugged in the 1 in for L right here and right here. So I get 225 minus 1 squared, so that's minus 1, so I get 224 divided by 4, which is 56. Now, if I want to find the volume, L squared times H. L is 1, so that's 1 squared, times 56, so that's 56 centimeter cubed. Okay? Now what you guys are going to do on your calculator, you're going to fill out this table for me. And then we'll discuss it after you guys are done.